From ContainerDays Hamburg, this video is proudly presented by DAX IT.
Hi, I'm Rene. I'm a cloud consultant at Shift Avenue. I've been working in the Kubernetes containerization space basically for my entire career. Also then focusing on Google Cloud, so coming from one of the major public cloud providers. Also working a lot there. This entire presentation, again, as Michael already said, is about how to integrate container image signing into your supply chain, into your Kubernetes supply chain. I will basically have two major parts in this presentation. There will be one theory part in the beginning, like just a few boring slides, giving you some introductory information, and then I will have a bigger demo part, which I hope that everything will work fine. But so far, all the other demos and the other presentations looked fine, so I hope it's also the case for me. Where I will then basically show you one popular tool, cosign, in action. So cosign is a tool which is basically used for container image signing. Okay, then let's get started. What actually is container image signing? To start, we can basically say that by default, container images are somehow anonymous. So you don't really know where they come from if you download them. Yes, okay, for popular images, you might all very easily find their GitHub repository if there's any, but still you can somehow treat them as anonymous. And container image signing actually tackles exactly this problem by just creating a digital cryptographic signature and adding it basically to your image and associating a specific version of the image with it. And this signature can then be used to verify the authenticity and the integrity of this image. You can basically treat it as any other signature or a signature of any other document, like I guess all of you or most of you have signed some sort of employee contract, and there's a signature from your employer and a signature from you. So to basically say that this document is like valid and an authentic document, so to say. And it's the same with this digital signature. And signatures are usually always created based on, or not usually, they are always created based on a specific image digest, so a specific version. It's always recommended to create those signatures based on the digest. You can also create it based on a tag, but tags are mutable anyway, so they can be overwritten. And B, if you use a tag, in the background, there will most likely be the digest anyway used to create this signature. So the digest that is currently associated with this tag. Now, why should you actually use container image signing? Well, I tried to print a super or create a super simple part of a say software or some sort of supply chain here, which basically starts after the image creation. This is where the important part for this session starts. And then at some point you have your container image in some sort of registry, and then at some point it gets deployed by either you do it manually or your GitOps processes or tools or whatever. And across the supply chain, there's a few attack vectors that are important or might be important in this case. One is that somebody might be able to push malicious images into a specific registry, and then also maybe create malicious workloads in your cluster. Now, I know if this is the case and this happens, you might have bigger problems, because usually you should not have access to those kind of resources. But just for the sake of simplicity, I'm focusing on the images part here. And if you configure your cluster to only trust a specific source of images or a specific set of images based on their signature, then you can basically prevent this because maybe those malicious images have a wrong signature, which cannot be decrypted, or they have no signature at all, and you can basically just block it. And it applies the same for images that are in your registry, or some of them which will be used to, or which somebody wants to use for, let's say, those malicious workloads. And the third vector is basically, as I said, sorry, forgot to enter it or to press forward here. You can basically verify that the image is from a trusted publisher, and this also helps for auditing purposes because you can track the origins from where you actually allow your images to be from. And the third vector is here that somehow the image gets modified, let's call it in transit. So somewhere in this time span between the images in the registry and then at some point gets deployed. And for the entire modification part, it's again important to understand that the signature is always based on a digest. And this digest is a unique hash value, basically created based on the content of the image or the content of the actual image manifest out of all the different layers the image consists of. And if there's a modification to the image, then most likely the layer also changes, the layer that is associated with, and this in the end creates a new digest because a part of this digest is altered. But the signature itself is only always associated with one single digest at the same time. So if the digest changes, the signature is not valid for it anymore. And with this, if you implement these container image signatures or the process, you can basically also protect yourself against some sort of modification between my images in the registry and it gets deployed to my cluster into my awesome pods. This is it for the generic theory part. I now want to present you shortly a tool which is called cosign. It's part of the Sigstore project. It's pretty popular. And in my session now, I will focus on the functionality that it can sign container images, but you can actually use it to sign other artifacts as well, generic blobs, any sort of files or scripts. And you have basically two approaches that you can use. One is a key-based approach. You have a public-private key pair. You sign the image with the private key and then decrypt the signature with the public key. And then if everything works fine, then the signature is valid. And if not, then there's something wrong, of course. And the second approach, which is also pretty interesting, is a keyless approach. It's based on an OIDC-based and uses your or some sort of identity to create this signature. This process also includes two additional components called Falkio and Recore. If I pronounce them wrongly, then sorry for that, but I thought it makes sense to pronounce them like this. So they are also part of the Sigstore project. I will come to them in the next slide because I wanted to show you this keyless signing approach in theory with some sort of flow diagram, so to say. Yeah, so on the left side, we have a user, and the user wants to use cosign to sign their image. The first step is always to build and push your image into your registry. It doesn't matter which registry, because if you want to create the signature, the image has to be present in the registry already, in the remote registry. And your image has some sort of tag and some sort of digest. So the digest is the SHA-256 whatever part in this text box below. And once this is there, you can start the process using cosign. The first part then is that you log into your OIDC provider of your choice, which is either GitHub, Microsoft, or Google. You use, for example, your personal email there. And this mail is then used as the identity in the next step, because then you'll use Falkio, or Falkio comes into play. Falkio is Sigstore's own certificate authority. It's used to create a short-lived signing certificate based on the OIDC token. And at the same time, cosign will also create an in-memory public and private key pair. The private key pair does not, the private key does not play any role in this process. It's basically destroyed during the process because it's not really used. What Falkio, however, does is it binds the identity to this public key. And all of this information is then used to create the signature. The signature will then be pushed to your container registry. It's also an object there. You can actually see it. We will later see it in a showcase. And the name of the signature is based on the digest of the image it's associated to. And as every other object, it also gets its own digest, but this doesn't matter here. And then also at the same time, Recore comes into play. Recore is Sigstore's own transparency log, and Recore basically witnesses the signing process by creating a log entry, which is time-stamped and also includes the signature, the signing certificate, and the public key. And then in all of these attributes, it basically also then contains the identity. And the attributes of the signature are, if you want to then verify the signature, then the attributes of the signature are compared against the log entry in Recore, and if this matches, then you're fine, and if not, then yeah, something's wrong or invalid, or there was some sort of error. And that's it actually already for the theory part. I now want to basically show you this all in action. So we will have a bigger demo part, as I promised. So let's again hope that everything works fine. I will switch to my Visual Studio Code for this. So first of all, can everybody like see it? Is it too small? Okay, perfect, nice. Yeah, so what I first will start with is basically signing my image with a key pair. As I said, the first part is always to build your Docker image. So this is exactly what I'm going to do. I will build my image. And my image is based on a sample app, which I want to show you right now. It's just a simple Go application, a web application exposed on port 8080. And if I just post a request to /, it basically just replies with hello ContainerDays, and that's it. And then I also have a Docker file here, which basically just builds the Go application and then runs this main binary during startup whenever I want to start this container or the image. So let's go ahead and build it. As the name, I will use the GitHub container registry as my container registry of the choice. This is my personal user in GitHub, and then just provide this name here and just call it v1 manual because I'm doing everything manually. Let's just build it. Oops, what did I forgot to -t. There we go. So this was pretty quick because I built it before. And now I also want to push this. So again, I will just use this here. I'm using a tag now. We will later then use the associated digest to sign it. So let's push it. This will not take that long. Perfect. And I will now switch to my browser, which already points to my repository in which I have the demo. I'm on the right side. You can see this packages section. If I click on this, I will find the v1 manual version in here, which then has a specific digest. So I will copy this, just paste it in here for a second, because now I will run the cosign part, or we'll start using the cosign part. You can generate the keys by running cosign generate key pair. This will now create this key pair on my machine locally, like a new one. Right now, it's just a RSA key, so to say, a key pair. You can also manage those keys in an external KMS system, like the ones from the public cloud providers or HashiCorp Vault. You can also store those keys as GitHub Action secrets. But for the sake of simplicity, I will just have them locally on my machine. So I will just run generate key pair. I will not enter a password because it's not needed here. And now I have this private key and this public key here. And as I mentioned before, I will now use this private key to assign the image, cosign.key, and now I will need to use, I don't want to type this again. I will just copy this one here. There we go. Paste it in here, then we use add because of the digest, and the digest is already here. Copy, paste, and there we go. Now it again prompts for password, but I didn't set any. Now you will have this prompt here. You basically some sort of need to accept the terms of service of Sigstore, so to say, because again we're relying on public projects here, public services. As usual with those terms of service, you don't read it and just press yes. And there we go. It's pushing the signature to my container registry. Go to my browser. If I refresh this here, we will see a .sig object here. This one. I hope this is also fine and you can read it. If not, just let me know somehow. Make yourself noticeable. One thing I wanted to show is the name here is starting with DA4 blah 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 blah. Oh. Click this, which basically matches the digest here. So again, this name is based on the digest of the image. And if I want to verify this, I just run cosign verify --key using the public key now. The auto-completion already points me to the public key. So this tool is, oh no, this is wrong. Let me just copy this again. Go, cosign, verify, key, then add, again, the digest. Let me also save this part for later if I need it again. And if we just now run this should work perfectly fine and will basically output attributes of the signature. Let me just expand this. Basically, including a few things here. There's also base64 encoded payloads there, which you can inspect for other attributes. I will not do this right now because of time reasons, let's call it like this. And yeah, this is the keybase part, pretty simple. The keyless part is even more interesting in my opinion. So the keyless signing approach. I will not run this in my terminal. For this, I wanted to showcase a sample integration into your CI processes. For this, I have a GitHub Actions pipeline here, which basically triggers whenever I push a change to my sample application on the main branch. Super simple. Once again, let me just simulate a change here as well. I'll go to the Go file and update this comment here. Then we'll just say that I massively improved the documentation. And then push this to main. There we go. It did not work because I need to pull it, I guess, first. What is happening here? Okay, let me just, does it work like this? I mean, it's just a demo repository. There we go. Yeah, and if I go back to my browser, I will just open the section here. And while this is running, should not take like a minute or so, I will just go guide you through this pipeline real quick. So we will just do all the things that I basically did manually before. We will install cosign with the official GitHub action and in our pipeline, log into the container registry, build and push the image, and then later sign it with cosign, again, based on the digest. The tag we will use is the commit char, so should start with 8e2 blah, blah, blah. And then for the signing process, we will not provide this key flag. We will basically omit this, provide the yes flag to basically auto-reply to all prompts. We had this prompt before. I don't want this in my automated pipeline because it requires user input. So I will basically auto-approve it like I did before because I didn't read through it. So yeah, let's go back to the browser. And if I refresh this here, it's still running. Once this is done, we should then, of course, see the new version and then the signature itself as well. We should again have this those matching names. Okay, it's already done. Perfect. So let's go to the packages section once again, and we have a new version here. The commit char was used, 8e2 blah blah blah. Click on this, and then the name is again of the signature object is again based on the digest. So we have add c4 blah blah blah, and this is the same here. And for the verification, we again use the cosign verify command. I just, oh no, I need this still. Let me close it. Let me close this, and I will just open this file, which basically contains the verification command. We will once again use the digest here. Let me copy it from here, the version I need. Put it in here. And now we will need to specify two other flags here. Instead of using the key, we will now use the used identity and the OIDC issuer, our provider, which in our case was GitHub. And the identity is not an email in this case. It's pointing to the to basically the file path of your GitHub Actions pipeline, and then also includes then the branch. And this is just how GitHub automatically sets the identity. If I would have done this from a terminal, I would have basically used my personal email or some sort of email, and we would see this in the identity. So I will just copy and paste this command, put it in my terminal. If I now run this, this should again work totally fine. This will now output even more. Oops. There we go. I don't want to click on this. Expand this here. There we go. It's even more than expected because now it includes the signing certificate, so a complete certificate and other additional properties as well. This is again, so this payload, for example, this body here includes the signing certificate. We could just use it, run a base64 code, and then just run this in OpenSSL to have the plain text output. And this would then include your identity, for example, and then other things. But I won't do this for now. Again, if this is a successful verification, then basically you will get this sort of output. Okay, awesome. So now we have those signed images, but I can still deploy anything on my cluster. I haven't shown how to integrate this into your environment. Now, for this showcase, I've created a local Kubernetes cluster with kind. I will just quickly check if this is up and running. Kind get clusters, perfectly fine. It is called ContainerDays. There's different ways you can implement this into your environment. You can use third-party components. I did this also in my test scenario. I am using the Sigstore's own policy controller. You can just deploy it with a Helm chart. You can also use Kyverno. I guess this is pretty popular. You can also just deploy it via Helm chart and then create a policy for this. There's also, if you use Kubernetes with certain specific container runtimes like Cryo and ContainerD, I guess, they offer built-in components to run those signature verifications. But this is harder to set up than just throwing a third-party tool in your cluster. So for the showcase, I decided to go with it. Now, the main component of Sigstore's own policy controller are cluster image policies. Let me close this. I will open this policy here now. Let me minimize this window also. There we go. So we have a cluster image policy. I want to apply this policy on all possible images. This is how you basically do it. This is a list. You could also define multiple image, image regexes or image names here. I just image all for this case, and then I have basically two authorities or two cases which I want to allow my images or my signatures to basically be from. I have a key-based encryption, decryption specified here, and then also the keyless scenario, which again points to my GitHub action and the OIDC issue, which is then basically GitHub. Now, as you can see, this public key here is not set, so I will just copy the value of my previously generated public key into this, and then just apply this cluster image policy on my cluster. So I need to format this. There we go. Save it. Expand this once again, and then run k apply -f ContainerDays demo policy controller policy. There we go. It's created. Now to apply this policy to your workloads, I need to add that for the policy controller, this is applied on a namespace level. I don't really like how this is handled, to be honest, because you also need to label the namespaces with a specific sort of label, so that the policy is actually applied on this. But yeah, there's ways you can configure this so it's auto-applied to every namespace, and you can rather exclude some of them. But the default behavior is to set this label, and I didn't change this for this showcase. So just to verify, I want to apply this policy on my default namespace. So we'll just get the default namespace, YAML output, and there you can see this label. I already did this when setting up this test scenario. Basically setting this value to true, so this policy is getting applied. Now, if I now want to run a test pod and use the image, I don't know, Nginx Alpine, this should fail. It checks this image, so the signatures against both scenarios. So one decrypting it with a key if it's possible, or otherwise the keyless part. We will then basically find this no signatures found 2 times in here. So this is one. This is the second time because it checks again against key and the keyless based approach, which does not work. Awesome. So we basically declined those anonymous images, so to say. Let's try to deploy one of my previously built images. I will use the digest of my manual image, which was signed by the key. So again, I will run run test pod -- image. I need to actually use this first, then put this at. I will go back to my browser, fetch the digest once again. Boom, there we go. Apply this, and it's perfectly working fine. For the keyless approach, I will just comment this out, just so you see that this also does not work. Once again, reapply the policy. So now we only have the key-based approach in here. If I now want to deploy my keyless signed image, run the same thing once again. Update the digest and also update the pod name. Test pod keyless. And this does not work because the signature does not, so it cannot be decrypted with this public key. If I now comment this in once again, just for the sake of completeness, I have now reapplied this, and if I now run this, it's perfectly working fine. If I run get pods, we will see 2 of them. Awesome. Okay, the one is still in creating. I guess it will just, now it's running. Perfect. And yeah, that's it. One thing I want to add is, as you can see in this YAML object, we basically have always a list of allowed authorities and also a list of allowed identities. So you can then extend this according to your needs. You can allow different keys to be used and then also a different set or a multiple identities. For example, you have 1 identity per repository. You can also specify regexes here, so regular expressions. So you can basically, for example, allow your entire GitHub organization as subjects in case you want this. And yeah, so you can be configured according to your needs. It's the same for Kyverno, for example. You also have a list of entries you can define here. And this is everything I wanted to show you today. I will go back to my presentation. I think actually that I'm way too fast, but I'm not sure. Oh, okay. Maybe I missed it. But anyway, let me just start my presentation once again. If you want to check out a few resources, I put them as QR codes here. One of them leads you to cosign itself, in case you haven't heard of it before. One link leads to my demo repository, and if you want to get in contact, you can also find me on LinkedIn, of course. And yes, that's actually it from my side. I hope you learned something today. I hope it was interesting. And I guess we can go to the questions if there are any. Thank you.
For the first question, does the signature get transferred if we move images across registries?
That's a very good question. I haven't tested out, but I would most likely assume no. You would need to basically recreate the signature once again. But I might be wrong. To be honest, I haven't tested it. But this is my assumption, at least.
The second question is, can you enforce signature verification before running the container?
I don't know if I understand this question correctly, but in my showcase, I basically verified it before the pod is running. So the entire policy controller, maybe I forgot to add this, or if you add this third-party component, they all run as admission controllers. So whenever you have those API requests going through going through all the components through the API server and all of that, then you have them running as admission controllers, so pods get rejected before they are actually being created. I hope this answers the question. If not, feel free to approach me afterwards.
Thank you. Do you really have to push before signing? Why does cosign 6 try to access the repository?
So yes, you have to push before signing it. It's why, to be honest, I am not sure. I mean, it has to be present in the remote registry. It's just a rule and enforcement of cosign itself. So yeah, I mean, it will try to access your container registry and try to push it there, of course. In my case, it was pretty simple because during my setup, I basically logged into my personal GitHub container registry, so it was basically using my credentials in the background. So yeah, I guess this again. I hope this answers the question.
Is it possible to run a pod without the use of the digest? I would expect that the policy checks for signing just using a specific image.
Yes, of course you can. just use a tag, and then in the background, I mean, if you check a image manifest of a running pod, you will always see in the image section maybe the tag, and then at some point down below, and I guess it's somewhere in the status, you will basically see that it points to a specific digest. It's always using the digest that is currently associated with the tag. You can, of course, do this. But again, those tags are mutable. They can be overwritten. So if you push this tag, somebody might overwrite it, and then you have different digests, but the signature was created for some older digest, an older version of the tag, if that makes sense. So this is why I try to go with the digest, because they are unique at any point in time.
Sense. Is it possible to audit or enforce signed images with policies like Kyverno?
This is exactly what I tried to do with my showcase. So I don't know, maybe I was too quick or something. But this is exactly what I did. So if you use this policy, every pod that would have been created gets checked against this. So it tries to verify if there's a signature, and if the signature can be verified, and if yes, then the pod is created. If not, then it's rejected before creation.
Next one is a great one. Is the key-based approach more or less secure than keyless? What would be the decision factor?
The decision factor is, so as I mentioned before, with so keyless makes of course more sense because you don't need to manage the keys. Keys are long-living secrets. At some point you would need to rotate them maybe, or it's always recommended to rotate them. And with the keyless approach, you don't have this. With the keyless approach, of course, in the end, you use Falkio and Recore. As I said, they are publicly available. Those log entries can basically be inspected by everybody. So there's also CLI tools you can use because every log entry gets a specific index, and you can use it to query this log entry. And you can actually, for example, see the identity. If you don't want this, you can set up your own Recore instances and your own Falkio instances, and basically not expose them to the public. But this is, so I haven't tested this out. The documentation states that it's pretty hard to do, so not that easy. So these are the considerations. I personally am a fan of this keyless-based approach. I would, for a production scenario, try to look into how to set up my own Recore and Falkio to see how this works. But yes, I hope this answers the question.
Thank you. If you have a non-public repository and the Kubernetes policy to not allow any image from other registries, would you still recommend signing, and if so, why?
This is a good question. So you basically say that you have one single registry, one internal registry. Well, this might be a case where you could actually think about it. I mean, in the end, it always adds an additional layer of protection, so to say. But would I still recommend it? To be honest, I don't know a good answer right now. This is actually a good question. So maybe it's then better to omit it maybe and just have a policy that only checks the origin based on the registry name. Yeah.
Yeah, maybe you can also take it offline and have a coffee with the person.
Yeah, sure, of course. I mean, I am still here today and tomorrow.
Perfect. Can you tell what exactly is signed? Image metadata, layer metadata, binary hash of complete image?
So the signature is created based on the digest. So it's then some sort of I guess it's then part of the metadata, or it's created based on the image manifest, which is not really for example, the Docker file. It's some sort of JSON document. I mean, we can also have a look at this afterwards. So in the end, you create a signature, based on the on the so-called image manifest, or this structure manifest, which is not identical to the Docker file actually.
Okay. Yeah, and I think probably it's also described in the documentation of cosign.
Yeah, sure. Of course, yeah.
What are the best ways to image signing in an air-gapped environment?
You can then use, of course, the key-based approach in this case. Other than that, if you do not have any internet access, again, you can also use the keyless approach by basically maintaining all of your components yourself.
Thanks. Can you add exception for Kubernetes-related images that gets pulled from public registries?
Yes, you can. If you, again, I can later show you in more detail. I don't think I can now switch back to my VS Code, but you can configure the policies that they only apply to specific image names, and then you can also basically exclude for example, any. What was the example? The public Kubernetes images, or what was the example? So you can basically exclude different repositories or image names there. You don't need to apply to all of your images.
What's the use case if the image are proxied through a private registry and deployed to air-gapped environments? Not sure I understand that question.
Yeah, I'm not completely sure. Again, I guess we can take it offline. Feel free to approach me. Yeah, I won't run away, or maybe I will. No, I'm just joking.
Okay, last one. How can an automatic script get the digest after pushing the image?
The digest is automatically. Oh no! How can an automatic script get the digest after pushing the image? I mean, if you download the image, if you pull it, you also have the digest in the end. You can, I don't know, if you run just Docker pull and then inspect your images, you will also have the digest there. So it's nothing that you need to fetch specifically, basically add an additional request when pulling your image.
And thanks for answering all the questions and for the amazing session. Thanks.
Thanks for your attention.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.